binomial expansion. Okay, binomial expansion. So it go like that. If I have A plus B or minus also can, doesn't matter. Okay, that means to the power of n. Okay, if I have A plus B to the power of n, or if I write like that, A, if it's a minus, I can say plus negative B, okay? To the power of n, it's the same thing. Yeah, so how it go? So it go by a combination. So it go in this way. So NC0. Okay, NC0, A to the power n, B to the power of 0. So this one go with the first term, this one go with the second term, the bottom. Plus, they are all together NC1 number of this type of terms when you expand. A to the power n minus 1, B to the power of 1. You see, the power of A go down, the power of B go up. So, and you see, this is n minus 1, and here is 1, here minus 1, here is 0, here minus 0, and here is power 1. Plus, it's going to continue with this pattern. So A to the power n minus 2, B to the power of 2. And it's going to continue until the last one, that is NCN, the last one. A to the power of 0, B to the power n. Stop. So this is a formula for binomial expansion. So if it's a minus, if I have this, A minus B to the power n. So I will write it as A plus negative B to the power n. So same thing. You will substitute in the same. So whether to have a plus or minus, that will depend on the power of B is odd or even. Yep. So this is called binomial expansion. So you can apply that for all the questions in 7G.1. Can or not? Okay. Yeah. So can I move to the next one? Okay. So we use technology. I taught you how to use it already. Yeah, 7G.2. Okay, any question you want me specifically explain to you? Look through the question first. Every time when you do a binomial distribution, you have to define your random variable x. So what is x? Can someone give me? What is x? X is the what? Is the what? Yes, skills. Okay, I make the online ones. Okay. Christopher. Since you go online, so you are very comfortable at home. Christopher, can you tell Ms. Do how you define variable x in this question? X is the
week of the year.
The week of the year. Okay, you see, if you read the question, they say the 8 a.m. bus will run late. Each day will run late. And then say for any week of years. So can you tell me what is the sample size? What is the number of n in this binomial distribution? Christopher?
5.
Hey, 1 week only got 5 days.
Sorry, 7, sorry.
So what is x then?
The day of the week.
The day of the week of what? The day of the week that I go for
Like-
online classes.
Now, how many days the bus will be late
In
in a week?
Thank you. So that is how you define. X is the number of days the bus will run late in a week. See or not? So that is how you define. You have to. So now in a week, so you know straight away from here, your n is 7. Am I right? So what is the probability the bus will run late? Huh? Hey, before you ask for probability, you have to build your binomial distribution first. I can answer this question straight away, but can you? That's why I say when you practice, you have to define, very important, your variable. Am I right? Even the previous one also. If not, when you write your folio 20%, the time you will die flat, I tell you. You think I purposely want to go through? I can just tell you, oh, this is an X, a binomial distribution. The probability is 2/5. And the n is equal to 7. I can just run through like that. Why I have to take so hard to ask you to define the variable X? In a day. So this is your probability of success. Am I right? So-called. So this is equal to 2/5. So when I get this right, then I will know that my X. So every day is independent of the other day, correct? This bus run late for Monday, it doesn't mean that it will affect on Tuesday, am I right? So they are independent strong. So I can convert this question. Is this situation a binomial distribution? Give a criteria for it that fulfill a binomial distribution. So there are 3 you can give me, am I right? There is a fixed number of trial, that is, we are talking about a set of number of days in a week. Then I can go to second criteria. For each day, there are 2 possible outcomes. That is, the bus run late, that is called success, or the bus doesn't run late, that is a failure. So your success and your failure always go hand in hand with what the question wants you to do. Correct? So you have to define properly. So I'm not going to find a probability yet. You have to understand the question fully first. So that whenever I change the question, you will know what to do, what to pick up first. Okay, so X is a binomial distribution. Yeah, the n is equal to 7, and the probability of run late in a day is 2 out of 5, that is 0.4. So it's easier for us to key into the calculator later on. Got it? Okay, so now, after we have got this, then we also have to tell ourselves what are the possible value for x, correct? That should be your habit. 0, 1, 2, until 7. Okay, what does that mean if I say x is equal to 0? That means none of the days in the 7 week, in a weeks, the bus is late, will be late. Am I right? Okay, so now let's go to find the probability bus being on time. So look, I keep saying late, correct? So if I read the question, my success, is it correct? No. So how should I put it? So after I read the question, I can change. So how should I put the success? So I'm going to cancel this off. This is not what the question wants. So how should I put the success? Being on time. So being, so I change, being on time. So is my probability correct? Wrong. Yeah, so nothing wrong. You read wrongly, you change, it's fine. 3 over 5. So change 0.6. So that's why it's good to read through the whole thing first. Okay, good. Now, so now we have everything in hand already. So now let's answer the question. Find the probability the 8 a.m. bus being on time all the 7 days. So that means probability of x equal to what? 7. So you put into your graphic calculator binom C PDF. Then put in 7, 0.6, and 7. Then you get the answer. Okay? So you can check the answer. Okay, now I want to go to part B. Okay. So be very careful when you read the question. You can check from the textbook the answer. I'm not going to give you the answer here. Okay. Can I move to B? Okay. Only on Monday. So there is a special criteria. So in this case, there is only one possible outcome. If I put Y as on time and N as late, so that means my only possible outcome for this will be Monday on time, Tuesday no, Wednesday no, Thursday no, Friday no, Saturday no, Sunday no. Done. Close. So can I use my calculator to count? Yes. That will be. Can I use binom's PDF? The answer is a no. you have to write this one as 0.6 to the power of 1 and 0.4 to the power of 6. And use a calculator to count. Because they say only on Monday. Clear? So you have to read the question very carefully. You have no choice. I tell you what, I can even change the question like that. Only on Monday or Wednesday. If I use the word or and I use the word and, is make a difference. You understand or not? If I make a or only on Monday and Tuesday, okay, it means that Monday is late, Monday is on time, Tuesday can be no, or both day also can on time, or only Tuesday can. So there are 3 possible outcomes here. If I use and, that means only one possible outcome. So you have to understand the word or and. Jelas? So you cannot play a fool with the word, especially statistic. Okay, let's go to C. Let's move on to C. On any 6th day, then this one, I can use this. Any 6th day. Then this one, I can use like that. X equal to 6. Because that is the meaning of X equal to 6. Okay, so you use your graphic calculator faster and count. Binom PDF. 7, 0.6, and 6. And you get the answer. Aswindaran, where is your graphic calculator? Okay. Let's go to part D. This one is very important. Probability of on at least 4 days. So when you have the word at least, means what? Minimum, correct? So you write as inequality, X must be greater than or equal to 4. Okay, so which means that my X is this. 1, 0, 1, 2, 3, 4, 5, 6, 7. I purposely list down this time, so I want all this. So I don't want all this. Correct? Why I say I don't want all this? The reason is because when you use your graphic calculator, you are going to use your binom CDF. So I have to rewrite this as 1 minus probability of, look at here, X. Less than or equal to what? 3. Get me? So now I can use 1 minus binom CDF. When you have less than or equal, then you can use binom CDF. 7, 0.6, and 3. Then you give me the answer. One, I make it longer. The other one, I make it shorter. Do you know why? One is shown by the graphic calculator. The other one is you round off to 3 significant figures. Habit. Clear? So good, huh? So through this question, you understand. You have to read the question carefully. Okay. Okay. Let's discuss one more question. That is question 10. Okay, let's discuss question 10. Okay. So how you define your X? How you define your X here? How you define your variable X? Because the question says if she is stopped at more than 11 traffic lights. So now you are talking about X is the number of time she is being stopped. Okay, number of times she is being stopped at a traffic light. Out of 15 traffic lights. Can I say like that? Okay. So what is the probability of being stopped? Probability of being stopped at a traffic light. So this will be the probability of success, right? So the answer is 0.6. So if you can get this one done, then you will know that X is a binomial distribution. The N equal to 15. They are all together 15 traffic lights that she has to pass through. 1.5. And the probability of being stopped is 0.6. So you are done. So then you can do your part A. Find the probability that Shelley will be late for work. How to define being late for work? If she is stopped at more than 11 traffic lights. Probability of being late is equal to probability of she is stopped at more than 11 traffic lights. So if I translate this mathematically, it will be probability X more than 11. So that means I want 12, 13, 14, 15. Am I right? So if I want to use my calculator and count, how will I write it? I will write it as 1 minus probability of x less than or equal to 11. Because when you use binom CDF, you must use 11 equal to, correct? So you write that down properly, then you use your calculator. You write down properly. This is 1 minus binom CDF x. Binom CDF 15, 0.6, and 11. So always write properly so that in the exam, you also know how to get the answer. So that is how you do part A. Okay, now how to do part B. Do you know you can go from one binomial to another? Can someone tell me what is the answer here? This is talking about a day, huh? Yes. Can you tell me what is the answer for part A? Hello, student? 0.909, huh? Why I need the answer? Do you know why? Because I need to do part B. Okay. So now let's go to part B. Can we? Okay. Let's move on to part B. Part B says, find the probability that Shelley is on time for work each day of the 5 days week. So now I have to define another one. That's my Y. Number of days on time for work out of how many days? 5 days. So this is a new way. Okay, so now, what is the probability that she will be on time for work in a day? Hey, wait, the probability of being late is so long, so high. You frighten me. Did you take 1 minus? Adoy. If I got the worker like that, I say you better. Don't work. You forgot to do 1 minus. Ayo. Mana. So this is equal to 0.091. Betul tak? Hello? So this will be on time lah. 0.909 will be on time. Am I right? So this is late. So please give me the correct answer. Hey, why the wrong answer? Everyone, I got so many students sitting in the class and yet didn't tell me the correct one. Very bad of you. Purposely make me confused, is it? Okay, on time for work in a day. So this is your probability of success for this case. Okay, so this will be 0. Sorry, apa cerita ni? Too cold, my hand. 0.909. 1 take away the answer from A. Understand? Okay, so good. So now find the probability that Shelley is on time for work each day of 5 days. So now I have to find the probability that Y equal to 5. Am I right? So I use binom PDF. N is 5. Probability of being on time is 0.09 for a day. And here is also 5. So is it high? Can you give me the answer? (0.6206). 0.6206. That is 0.621. Is it correct? Is it correct? Did you all check the answer from the back? I better check it myself. Cannot trust that one, you know. 7G.2. Yes, 622. I think the back answer got 622 is the way they take this one. That will make a difference. Yeah, so it doesn't matter. Okay, you want this out worker or not? Chances of every day early for work only 62%. That means definitely. Okay, now. Okay, now how are we going to do part C? Shelley wants to increase the probability in B to at least 80. She decided to leave home a little earlier. So she must now be stopped at more than 12 traffic lights. Okay, look, that means when you want to do part C, right, the number of traffic light changes. So you have to repeat part A and part B all over again. You have to repeat part A and part B all over again. They say, so she must now be stopped at more than 12 traffic lights in order to be late. So you have to do your part A. You find the probability of X more than 12 traffic lights. This is probability of being late. So you have to repeat part A and part B all over again. Being late for work in a day. So can you give me the answer? This will be 1 minus probability of X less than or equal to 12. So that is how we justify the answer, okay? So what is the answer? 0. 0 what? Apa cerita ni? 0.027 what? 1. Okay. So that means probability of being early for work in a day will be equal to 1 minus 0.0271. That is 0.98. No, 97. 9729. Am I right? Okay, so now, therefore, probability of y equal to 5. So you use binom PDF 5, 0.9729 and 5. Does it achieve 80%? Ada tak? Got or not? Got achieve or not? Yes or no? Yes. What is the probability here? 0.98. 872. So this is 87.2%, which is more than 80%. Yes, she achieved. So you justify. So therefore, she achieved her goal. So that is how you justify. So sometimes I can change this question. I say, how? Okay, how many traffic lights? At least how many traffic lights must it stop? Being stopped to achieve the goal of being early for work all the 5 days in a week. To 80%. So you have to do try and error. So we will discuss other question that is talking about try and error. So bear in mind, from one binomial, I can get into another binomial. And later when you do all the past year question, this can be happen. I can also get from one, later we study chapter 8, from a normal into a binomial. Do you get me? That is how you answer question like that. Okay, so can you please try exercise 7G, all the question there. So next week I will teach about what is the meaning of mean and standard deviation. So we still got 5 minutes, correct? I might as well settle this. You want me to settle the meaning of the mean and the standard deviation for binomial distribution? Yes or no? Okay, no, we can do it on Monday. Alamak, so happy. I thought student, you are supposed to make full use of your time. Okay, so done. So I will talk about mean and standard deviation next week. Yep. Thank you, class.